All right, so we're going to be looking at functions. That's our new unit. So basically any type of function that will be linear, that will be quadratics, but there'll be some other ones too. But we're also going to be doing other things with functions. So this one's, the one, just kind of watch what I do. Okay, so just know that if I'm asking for f of anything, like here it's f of 2, that 2 is going to be substituted in for x for every position that x is located in. So what happens is the 2, see this is f of x, so there's an x here and an x here. If this was a y, there would be a y here and a y here. This was a, there would be an a and an a. So f of 2, I've now replaced the x with 2's. So, we do the order of operations, we get 4 plus 6 minus 7, which gives us 3. So now we're doing negative 2. Plug in negative 2 everywhere there's an x. Okay, and we get 4 minus 6 minus 7, and we get negative 9. So basically what I wanted you guys to see is that whatever's in here replaces the x. Okay, I could put anything in there. All right, we'll be doing that today. Okay, so today's lesson is functions, and you will determine if a graph is a function and also evaluate functions at given values. Okay, so the first thing is function notation. So we've already looked at linear and quadratic functions, and we've already done this where we know that the y can be replaced by f of x, or if we don't like f of x, we can make it g of x. If we don't like g of x, we can make it h of x. Okay, but the most common one, of course, is f of x, so I'm going to leave it as f of x. Okay, now my input values are my x values. My output values are my y values or my f of x. Okay, so you input this to get out that. So like if we want to find f of 4, that means I'm going to input 4 into f. Okay, so where there was a variable, which is x, that's where 4 is going to go. Okay, and then using the order of operations, of course, we get 5 minus 32, which is negative 27. Okay, so my output is negative 27. So I know that f of 4 equals negative 27. And that, of course, produces the coordinate 4 comma negative 27. That's the input output. And of course, these input outputs direct the shape of the graph for that function. Okay, so whatever's here replaces the variable x, or whatever variable was there. Okay, so basically, whatever you put in here goes there. So m, and that's m. 7, that would be a 7. Okay, you got the at symbol. That would go in there. If Mr. Sexton was in there, then you would put Mr. Sexton in there. Not that you want to, because Mr. Sexton's already a perfect square, so you wouldn't want to do that. All right, so let's say we have this, and we know that this is a quadratic function, and we want to find f of now x plus 1. So now instead of putting just a number in, we're putting in an expression, and in this case, it's a binomial. It's got 2 terms, a binomial. So we're going to take this x plus 1, and we're going to plug it in everywhere there was an x. Okay? So just like if this was a 4, you'd put a 4 here and a 4 here. But this is x plus 1. So we're going to substitute and put x plus 1s in each of those locations. Okay, so it was 2x, but now it's 2x plus 1 squared. It used to be a minus x, now it's a minus x plus 1. And then the plus 1, there's no x there, so it just stays like that. So now we can simplify this. Okay, we'll distribute the negative, we'll FOIL this out. Hopefully you guys will, remember the shortcut for squaring a binomial. You square it, multiply them together and double it, and then square this one. So x squared plus 2x plus 1. Okay? And then distribute this. You get negative x minus 1, and then you have a plus 1 at the end. Now we can distribute the 2. And then those can cancel out. And now we can combine like terms with the 4x and the minus x. And we end up with this. Okay? So this is f of x plus 1. Okay? And I mean, if you dive deeper into this, really what you're doing is you're creating a rule. You're creating a formula for x plus 1 values. So if you wanted to know what the plugging in, what the next number would be if you had a 4 and you want to know if you plugged in 5, what you get, well, you could plug 4 into that function, and that will give you the answer is if you plugged in 5 into the original one. So it's like a rule or a formula. That's how formulas are created, is by doing this at times. Okay, so that is our f of x plus 1. Okay, so eventually we will look at the difference quotient. So let's say we want to know f of 3 minus f of 2. Okay, it's actually pretty straightforward. If you just took f of 3 and then subtracted f of 2, you would get your answer. Okay, but of course if we're writing it out, we would have to, we went ahead and put 5 minus 2 times 3, so this is f of 3. And then when we subtract f of 2, we want to make sure that we put it in parentheses because there's that minus sign right there. Okay, so this is going to actually come into play later on when this is an expression. Okay, so we put these parentheses with a minus in front. So now we can simplify. I mean, in this case, it's not going to matter because we're going to simplify before we subtract anyways. But technically, we need to have those parentheses. So we got 5 minus 6 minus 5 minus 4, which of course is negative 1, minus 1, which gives us negative 2. Okay, so here's one where we have an expression and we have a numeric value. Okay, just follow the steps. Follow what it's telling you to do. So we need to find f of x plus 1. So we're going to plug in x plus 1 into here and then get a new expression. And then we're going to subtract f of 1, which means we'll plug 1 in and we'll actually get a number. Okay, so follow what it's telling us to do. So f of x plus 1. Let's plug in x plus 1 here. So this right here is f of x plus 1. So what this is has been replaced with what it is. And then we're going to subtract f of 1. So if we plug in 1, we get 1 squared plus 3. Okay, so I'm going to go ahead and FOIL this out. Remember the shortcut, square, multiply together and double it, and then square. So x squared plus 2x plus 1. Then I got the plus 3, and then 1 squared plus 3 is 4. And now I can simplify. Okay, I could combine like terms. So this will be 4, but we're subtracting 4. So we end up with x squared plus 2x. Okay, and that's common for that to happen, especially when we're actually doing the difference quotient, which is something you'll see. I think it's coming up here. The constants at the end cancel each other out, as long as it's set up in a certain way, like it is here. So it's f of x plus 1 and this f of 1. Okay, let's try that again. So notice we have f of x plus 3, and then we're subtracting f of 3. Okay, so again, let's look at f of x plus 3, which would be plugging in x plus 3 here. Okay, so that's what this is. So we've got that done, this part here, this f of x plus 3. Okay, we're We're not doing anything where we're plugging stuff in back this way. It's just pretend like this is like its own problem, which this is what you would do. And then you would subtract this own problem, which is f of 3. So we would just plug in 3 for every value of x. Okay, so here's my f of x plus 3 minus f of 3. So now I'm going to go ahead and expand this out. So remember the shortcut, square, multiply together and double, and then square. So x squared plus 6x plus 9. And then distribute. So negative 2x minus 6, put a plus 1, and then I'm going to simplify here before I could distribute if I wanted to, but why not just make this its numeric answer and then just subtract it at the end. Okay, so 9 minus 6 plus 1 gives us 3 plus 1, which gives us 4. And notice over here what I simplified. Okay, I got my x squared, 6x minus 2x is 4x. Okay, I've got 9 plus 1 is 10, minus 6 is 4, and then I got a minus 4. And again, look what happens. My constants at the end there, they cancel each other out. All right, and that's because of the way this is set up. Okay, because that's a 3 and then that's a 3. That's going to happen. Okay, now it says try this one, but let's kind of work on it together. There's a lot going on here. So do it like we did before. So you have its own problem. You've got g of 2 plus h. And then you're going to subtract just g of 2. And then after you're done, you're going to divide by h. Okay? So exactly what we've done before. So let's think of just g of 2 plus h. That means I'm going to plug in 2 plus h here and here. Okay, there's going to be a lot going on. So you need some room. So I'm going to do 2 plus h squared plus 3 times 2 plus h minus 4. So that's that part right there. That portion is done right there. I don't need to do anything with the h because the h is just divided by h. That's it. And then I'm going to subtract g of 2. So I'm going to take this 2 and I'm going to plug it in here and here. Okay. And I can simplify out. Okay, remember the shortcut? 4 plus 4h plus h squared. And this will be 6 plus 3h minus 4, and then this will be 4 plus 6 minus 4. So again, this part is the g of 2 plus h. There's the minus sign. That's this minus sign. This is g of 2, and then it's all over h. Okay, so we expand this out. And then I think I just do minus whatever this is. So 4 plus 6 is 10. Minus 4 is 6. So there should be a minus 6 here. Okay, let's simplify more. Let's combine like terms. So it looks like we've got these 4's will cancel. These 6's will cancel. And then we've got 3h and 4h is 7h. So we've got h squared plus 7h over h. And again, if we separated, we'd have h squared over h plus 7h over h. So the h's will reduce. And we end up with h plus 7. Okay, see how it's simplified nicely? Turned into just h plus 7. Okay. There's a lot going on there. Okay, this is what's called the difference quotient. That's something that you would see in calculus. And there actually is a shortcut to it that you would learn in calculus too. But you got to understand what we're actually doing with this. We're actually finding the slope of a tangent line at that given point of 2. Okay, so I think I show it here. So we have, this is g of x, right? This is the parabola because it's a quadratic function. And if you go to 2, right? So at 2, your function's right about there, okay? And if you drew a tangent line there, that tangent line actually has a slope of 7. Because really this would have a limit and the h would approach 0. So that would turn into 0, so the slope is just 7. So a tangent line is a line that touches at a certain point. Only touches once at that point. So this tangent line has a slope of 7. That's really what you found by using this difference quotient. Okay? And you'll see sort of this formula later on too. Okay, so that's why it says m equals 7.